Hey guys, welcome to the 4.1 notes video. I'm going to try something new with notes this unit, and you will notice that on the left side of your notes sheet, there's just a bunch of information already filled in. These are like your conceptual things, and then over on the right side is when we're going to actually practice with it. So this entire unit is about polynomials, and a polynomial is just a fancy word for an expression basically, and it's going to have three things: constants, variables, and exponents. There are two rules that polynomials have to follow. There cannot be variables in the denominator, and they must be written in standard form, which essentially just means you're going to have various exponents on x, but they need to be listed from highest to lowest exponent. Then, if the highest exponent is in front like it's supposed to be, the degree will always be the first one. The degree is just the highest exponent of a polynomial. If that exponent is 1, it's called linear, like y equals mx plus b. If it's quadratic, that's x squared. If it's cubic, that's x cubed. And if it's quartic, that's x to the fourth. And that's just a way of naming polynomials. Next up is a word I've used all year so far, but I wanted to take just a moment to stop and make sure everybody understands that a coefficient is just a number in front of a variable. And a variable is just a letter. So for example, 2 is a coefficient, 5 is a coefficient, this 3 is a coefficient. Those are all coefficients because they're next to letters. But a constant is a number that does not have a variable. Like this 4 or this -3. Those are constants because they don't have a variable with them. Then we have terms. These are just the parts of a polynomial. They have to be separated by a plus or minus sign. So for example, right here, this one would be called a trinomial because it has 1, 2, 3 terms. Again, I've talked about that, but I just want to be very clear that they have to have a plus or minus in between. For example, the 3 and the x in the middle there count as one term. You can name a polynomial by its number of terms as well. These are a little easier to remember. Mono means 1, bi means 2, tri means 3, and poly means 4 or more. So I've used the word trinomial because we were working with them before. And the reason why I'm going over this vocab now, guys, is because I'm going to be using these words as we start to talk about polynomials. And then last thing is like terms. They are the ones that you're allowed to add together. They just have to have the same variable and power. And we're going to go ahead and add and subtract some polynomials. All you do is you add the coefficients unlike terms, but you don't change the exponents. So let's go ahead and get into a couple of these so that it makes a little bit more sense. And I'm going to clean this up just a little bit. There we go. Okay. So let's go up here to the top. If I want to add these polynomials together or subtract, I just have to add like terms. And since it's supposed to be listed highest to lowest, I'm going to look across this entire problem and I'm going to pick out my highest exponent that I see, which is right here, -5x to the third. And there's no other x to the thirds, so I'm just going to keep it -5x to the third. And then I'm done with that one, so I'm going to go ahead and cross it out. Then I'm going to add together my x squareds. 3x squared plus 8x squared is 11x squared. Now I'm done with those, so I'm going to cross them out. And I'm going to move on to my x's. -9x plus 4x. -9 plus 4 is -5x. Cross them out. And that just leaves me with this plus 11 at the end. There's no other constants, so that's it. Okay, I'm going to do the same thing on the next one, but before I start, I'm going to go ahead and distribute this negative. which just changes the signs of everything. And then I'm going to do the same thing I just did. The highest exponent I see, again, is x cubed. I've got 4 minus 2, which is 2 x cubes. Then I'm going to add together my x squareds, which there's only one of them, so it's just 2x squared. Then I'm done with that one. And I add together my x's. 7x minus 8x is negative 1x. And then 3 plus 5, and actually I think, let's go check. Yeah, that was negative 3. Negative 3 plus 5 is 2. And those are my answers. Now let's talk about multiplying. We've already multiplied before, so we're really doing the same thing we were doing, but you'll notice that this problem on the right side has more terms than we have seen before. It looks a little bit longer, so I'm going to talk about what difference that makes. But over here on the left, you're just going to make sure you take this 2x from the first parentheses and multiply it to both of the others, and then you take the 4 and multiply it to both of the others. So everything from the first parentheses gets multiplied to the second one. So 2x times 5x is 10x squared. 2x times negative 3 is negative 6x. And then I'm going to take the 4 and multiply it by 5x, which is 20x. And 4 times negative 3 is negative 12. And then you're not quite done. You have to add together the 2 in the middle. Negative 6 plus 20 is 14. And that's it. Now let's talk about what we're going to do on the second one, because there are 3 things in the first parentheses. So all 3 of them have to get multiplied by both of the things in the other parentheses. Like this, and then this, and then this. And for me, that looks kind of confusing, and I lose track of what I'm doing. So instead of doing it like that, I'm going to use what I call the box method, where I'm going to write the first parentheses on the top of the box and the other parentheses down the side. And I'm going to draw a row and a column wherever I see a plus or a minus sign. Then I just have to multiply these 6 things out, so I can see exactly what I still have left and exactly which parts need to be filled in. So for example, I'm going to do, for this square right here, I'm going to do x squared times x squared, which is x to the 4th. And then moving to the right, x squared times 3x is 3x cubed. X squared times 1 is x squared. And then I move to the bottom row and I multiply everything by negative 2. X squared times negative 2 is negative 2x squared. Negative 2 times 3x is negative 6x. And negative 2 times 1 is negative 2. And then I'm going to add together my x squareds, which this one right here is really 1x squared. So negative 2 plus 1 is negative 1x squared. I'm going to put the x to the 4th and the 3x to the 3rd in front, and the negative 6x and the minus 2 at the end. Notice how everything I've done has gone decreasing in powers. 4, 3, 2, 1, none. It's always going to do that every time. So since this one started with x to the 4th, it should go x to the 4th, cubed, squared, x to the 1st, constant. You do not have to use this box method. You can write everything out if you want. I'll show you what that looks like on the next one. I will also show the box method on the next one as well, too. So if I'm not using the box method, I just have to be careful and go one at a time. X squared times x squared is x to the fourth. X squared times negative 5x is negative 5x cubed. And x squared times 2 is 2x squared. Then I'm going to multiply everything by 3x. 3x times x squared is 3x squared. And notice where I'm going to write there, 3x cubed. I'm going to write that underneath the other x cubed. And then 3x times negative 5 is negative 15x squared. And then 3x times 2 is 6x. And then, last but not least, I have to take the 1, the last number that I haven't multiplied, and multiply it by all three of them. Good news is when you multiply by 1, you don't actually change anything. 1 times x squared is just 1x squared. 1 times negative 5x is negative 5x. And 1 times 2 is 2. And then you just add together your like terms. But you'll notice that I have lined mine up in columns like this. You don't have to draw those lines, by the way. In fact, I'm going to go ahead and undo that because it just looks a little confusing. X to the fourth stays in front. Negative 5 plus 3 is negative 2 x to the third. 2 minus 15 plus 1, that's negative 13 plus 1 is negative 12 x squared. 6 minus 5 is 1x. And then the 2 doesn't add to anything, so it stays as 2. Okay, if you wanted to use the box method, it would look like this. And then I would multiply everything together, and I would get x to the fourth, 3x cubed, x squared, negative 5x cubed, negative 15x squared, negative 5x, 2x squared, 6x, and 2. Everything that I just did there is the exact same thing as I got on the other side. But the one nice thing is that my like terms are here along the diagonals. So I don't have to worry about lining them up. They're already lined up for me. So this would add to the negative 2x cubed. That would be my negative 12x. And this diagonal would make my negative 1x. So I get the exact same answer, whether I use box method or not. It's just a way of organizing your work. Okay, let's talk about special products. If you ever notice that you have the exact same thing in both parentheses, except for one of them is plus and one of them is minus, you're just going to multiply the first two, 16x squared, and the last two, negative 9. The reason for this is because the middle is going to cancel out. If I multiplied everything like I'm supposed to, I would get 12x and negative 12x, which adds to 0. So that's why there's nothing in the middle right here. And you can use that shortcut whenever you want. Hopefully you're starting to recognize that because we've talked about it a few times. On the next one, though, because it's being squared, that means you're multiplying it by itself. So you're going to have to multiply 5x minus 2 and 5x minus 2. But this time you'll notice that they aren't opposite signs. They're both the exact same sign. So they're not going to cancel. Instead, the middle part is going to double. So you can still square the first one and the last one. But in the middle, instead of canceling like I did on the last one, you go ahead and multiply these two together, which 5x times negative 2 is negative 10x. and then you multiply it by 2. And the reason why it's doubling is because you would get negative 10x and negative 10x. So you get the same thing twice. That's why you're just multiplying it by 2. This one isn't as much of a shortcut, but it does save you a little bit of work once you get used to the pattern. So these two things are just shortcuts that you can use if you want to, or you can take the long way out and multiply it out every single time if you don't trust the shortcut. All right, and this very last one, I have to go ahead and multiply first because in my order of operations, PEMDAS, multiplication and division come before addition and subtraction. So I'm going to have to do this part first, and then I'm going to add in the other parts afterwards. So I'm going to go ahead and multiply x squared times x cubed. X squared times negative 4 is negative 4x squared. 3x times x is 3x squared. Notice how I'm writing that underneath the other x squared. 3x times negative 4 is negative 12x. And lastly, negative 5 times x is negative 5x. And negative 5 times negative 4 is 20. Then I'm going to go ahead and bring this in and write it right here. And add all of that together. So I get x cubed, negative 1x squared, negative 12 minus 5 is negative 17, plus 9 is negative 8x. And 20 minus 15 is 5. So there's just really like 2 steps where I multiply it all together here first, and then I add in the other part at the end. That's it.